Hello, my esteemed student out there. It's so good to see you once more. This time around, we are looking at the fourth series of video of our UTME videos, and we're going to look at a very great topic today, indices. But then I know you did the quizzes I gave to you on the previous topic. Remember the previous topic? Everyday mathematics and percentage. Now, if you're able to solve those quizzes very well, I guess you should be able to get the results that will be displayed on the screen. Now, I want you to take note. The solutions of these results are well explained in our ebook series. So if you want a detailed solution of these questions, you can grab our ebook for the series. Just download any of them. The series, the first series, UTME series 1, you see a solutions to this question. Now, look at the questions and see if you get it right. I'll be right back. Now you're welcome back. As I told you earlier on, our topic for today's video lesson is going to be indices. Now, at the end of this topic, at the end of our discussion, you should be able to carry out the following. Apply the laws of indices in solving problems. And that is exactly what we are going to look at throughout the course of our discussions. Now we want to look at the challenge question for this topic. Can you solve the questions that are displayed on the screen? Now those questions displayed seems pretty difficult, right? But stay tuned and locked in to the end of these videos to see solutions to each and every one of these questions. I won't tell you they are pretty simple, but then we're going to solve them together. Now to start with, let's delve into the introduction of this topic, indices. Now, an index is a number, that is the singular of indices, is a number which is raised to a power. Now, the power, also known as the index, tells the number of times you have to multiply the number by itself. For example, 8 raised to power 4 means that you have to multiply 8 by itself 4 times. That is 8 times 8 times 8 times 8, which will give us 498. Now there are a number of important rules that we need to take note of in solving index numbers, and these rules are explained in the keynotes that we'll be analyzing one after the other. Now the keynotes contain the rules, and these rules are useful in carrying out problems involving the laws of indices. We are going to look at the first rule. The first rule is the product law. Now this product law says when you have a value that is raised to a given power multiplied by another, that same value raised to another given power, the result will be the value raised to power the addition of the two powers. You see it displayed on the screen. The second one is the division law, which says when you have a given value, let's say x raised to power a divided by x raised to power b, your solution will be equal to x raised to power a minus b. Now the third one is a law we call the power law. The power law says when you have a value x raised to power a and all of them are raised to power b, your solution should be equal to x raised to power ab, which is equal to a times b. Now the fourth laws I want you to pay attention to is the zero index law. This law says when anything is raised to power 0, it is equal to 1. Now we also have the fifth law, which is the negative indices law, and that law says that if you have anything raised to a negative power, your result will be 1 over x raised to power that value. That is if you have x raised to power minus a, your result should be equal to 1 over a raised to power x raised to power a. Finally, we're going to look at the fractional indices or the root law. Now, if you look at this root law very well, if you have a given number as a base and it is raised to power a fraction, let's say x raised to power 1 over a, your result will be the a square of x. So if you have your a to be 3, it will be the square root. If you have your a to be 2, it's going to be the square root of x. If you have your a to be 3, it's going to be the cube root of x. If you have your a to be 4, it's going to be the fourth root of x, and on and on. If you have a value x raised to power a divided by b, which is a fraction, the result will be b, the b root of x raised to power a, or the b root of x and all the value will be raised to power a. Now, if you look at the seventh keynote, the seventh keynote talked about some indical equation. Now, if you are given an equation like this, if you say if you are given 4 raised to power x equal to 1 over 64, and you are asked to solve for x. Now, solving this question requires you to create a common base. And what I do in this instance is to make sure that I raise the powers of most of these numbers to a smaller value in which they can be able to cut off themselves. Now, what do I mean by that? You can see on the screen, 4 raised to power x is equal to 2 raised to power 2, that is all multiplied by raised to power x, and the other value 64 will give you 2 raised to power 6. So to simplify further, you come to see that the base, which is 2 and 2, are common and they will be cleared off. So that will now leave us with the powers. Now 2x is equal to minus 6, so our x now will be equal to minus 6 divided by 2, which is equal to minus 3. Now you see, if you follow these rules, if you follow these samples I've just showed you, they are just keynotes, and if you can follow them judiciously, you are going to end up solving indices as simple as anything, and you're going to find great fun solving indices. Now I want us to start solving. Let's look at those challenge questions I gave you, and let's see how we go about solving them. Remember, I said we are going to solve them together. Now let's go to sample 1. Sample 1. Now let's look at the solution to the first sample on this topic, indices. The question says 27 raised to power x plus 2 divided by 9 raised to power x plus 1 equal to 3 raised to power 2x. Now to go about this, we remember the smallest, these are called the bases. Now the smallest base we have is base 3. Now, don't you think it would be very good to ease our work? And to do that, we want to make these other ones, since they can be done that way, to have the same base with this. That way, we can be able to make our solutions very easy. Now, let's go about that. Now, 27, 3 raised to power 3 definitely will give us 27. So this will be this plus 2, right? Good. Now we want to look at divided by 3 raised to power 2 will give us same 9. That will be multiplied by this plus 1, right? And that will be equal to 3 raised to power 2x. Remember, we are looking for the value of x. Now, this can be compared to exactly what I did in our keynote 7. I guess you remembered. Now, following the laws of indices, the second law, division law, that is keynote 2. It says when you have two values of the same base dividing each other, the powers will be subtracted. You will subtract the powers. Now, to carry out that, we will see this common base will be 3 raised to power 3x plus 3 times this is 3x. This times this will give us 6 minus 2x plus what? Plus 1. That is exactly what it will give us. And these two will be equal to 3 raised to power what? 2x. Now, do you notice something? Let's simplify further. This will be equal to 3x plus 6 minus times 2x. That will give you minus 2x. Minus times plus will give us minus 1. And that will be equal to what? 3 raised to power 2 what? X. Now, do you notice something? That these two things have one common base now. It simplifies the whole thing for us. This can just cut off this, and we'll be left with the powers. So our powers now will now be equal to 3x plus 6 minus 2x minus 1 equal to 2x. So all we need to do now is to collect like terms. Now, terms with x will come over this way, and terms without x will go over the other way. Now we have our 3x minus 2x plus 2, cross the equal to sign to give us minus what? 2x, and that will be equal to this go over here to give you what? Minus 6. This crosses this equal sign to give us what? Plus 1. So 3x minus 2x will give us what? X minus what? 2x equal to minus 6 plus 1. That will give us what? Minus 5, right? So x minus 2x will give us minus x equal to what? Minus 5. So in this instance, minus will clear off minus, and our final result x will be equal to what? 5. Now you see, given this value, you are asked to look for x. Our x will be equal to 5. Take note, these questions are questions that will be given to you in the first part of your examination, part 1, which are the objectives. And you are expected to spend not less than 10 seconds solving these questions. So if you are familiarized yourself with those topics, with those rules, you will see application of these rules in these questions, and then you get your answers in a jiffy. Now let's look at the second sample, sample 2. Now the sample 2 question for our topic today is solve for x when x raised to power minus 2, 8x raised to power minus 2 is equal to 2 divided by 25. Now, these questions seems very difficult because of all the minus you see, but it's very easy. Now, let's look at it. We are given 8x raised to power minus 2 equal to 2 over 25. Now, looking at this question very well, that's the first thing a very good mathematician will do. Look at the question thoroughly. Now, you notice that this raised to power minus 2, 8 is not raised to power minus 2, but the x is raised to power minus 2, right? Good. Now, that should tell you something, that we are going to use a rule to break this down. Remember the negative aspects of our laws. Rule 5, law 5, keynote 5, negative indices. Now, this will give us, if we apply that rule, we'll have 8 times. That rule states that if you have x raised to power minus 2, it will be equal, right? Good. Now, if you apply it here, we'll have a 1 raised to power x raised to power 2. That will be equal to 2 over what? Over 25. Now, you've come to see now that this will be equal to 8 divided by x squared, because 8 times 1 is 8, equal to 2 over 25. It's becoming simpler. Now, all you need to do is to what? Is to cross multiply. Now, if you cross multiply here, what will you get? You have your 2x squared equal to 8 times what? Times your 25. Now, 25 times 8, if you multiply it very well, you're going to have 200. And this will be equal to what? 2x what? Squared. Now, we want to clear this x from here. Now, we'll have to divide both sides by what? By 2, right? Good. So, if you divide this, 2 will cut 2. And 200 divided by 2, our x squared will be equal to what? 100. Now, let's go. Now if you bring that 100 here, we are going to have our x squared equal to what? 100. Now how do we clear this square? The only way we can clear this square away from x so that we can get the true value for our x is to what? Is to square root what? One side is carrying what? A square. Now if one side is carrying the square root, you have to square both sides so as to clear the square root. Now let's look at that. This 100. Cut off this square root. We'll have 10. Remember the question, solve. That is what they ask you to do. So your solution should give you a specific value for what? For x. Can't you see how easy it is? I told you mathematics is fun, and solving it is fun when you take it a step at a time and you follow the rules. Now, following these rules, we've seen that we've arrived at the final solution of x. Our x is equal to 10. Now, let's look at the final sample. I guess you understand this. Let's look at the final sample for today, the sample question 3. Now, the third sample for our video today is simplify. Now, remember the previous one, they asked you to solve. This time around, they say simplify. It seems complex. You're seeing a fraction raised to power a fraction and a fraction raised to power a negative fraction. Don't despair. We're going to solve it. Just follow me as I solve and you'll see a solution to it. Now, if you are given this question next time, what you need to do first is to ask yourself, is there any way I can break down these few questions, these few fractions, so that they can have the same power with this external denominator, this fraction below? Of course, it can be possible. Now, let's go about doing it. Now, if you look at that, you come to see now that you have 16. 2 raised to power what will give you 16? 2 raised to power 4 will give us 16. And if we come to take this, what can we raise to power that will give us 81? That will be 3 raised to power 4. All will be raised to power 1 over what? 4. Because 3 times 3 times 3 times 3 will give you 81. So you see, you simplify this. Now let's go ahead. We'll have this other one. 9 raised to power 2 will give us 3 raised to power 2 will give us 9, right? And this other one, 4 raised to power 2 will give us 16. All are raised to power the fraction minus 1 over 2. We are gradually simplifying it. Now let's go. We'll take this inside and this will give us 2 raised to power 3 all out 4 times what? 1 over 4. Divided by all in 3 over 4 out 2 times minus 1 over what? 2. Now it makes it more easier. 4 can now cut 4 comfortably. 2 can now cut 2 comfortably. What do we have remaining? We'll have this value, 2 over 3 into bracket 1, which is not necessary, divided by 3 over 4 bracket raised to power minus 1. Now remember the negative law we told you. A raised to power minus 1 equal to what? 1 over a raised to power 1. Or if you have a raised to power minus x, it will be equal to 1 over a raised to power x. Remember that rule? We're going to apply it here. So this will give us 2 over 3 divided by 1 over 3 over 4. Now if you take this further, this will now be equal to 2 over 3 multiplied by, or let's not go to that, let's look at this. If you divide this further, this is going to give you 3 over 4, because it's just like when you have 1 divided by 3 over 4. You have 1 divided by 1 times what? Times 4 over 3, right? That's what it will give you. So this will give you 4 over here, right? Now, are you getting it? Now, this will give us 4 over 3. So this value now will now be equal to 2 over 3. Division sign changes, the power 3 comes up, this goes down. So 3 will cut 3, and this will give us 2 over 4. Simplifying further, 2. So our final solution will be 1 over 2. Now, do you see that question that seems like a giant, that seems so intimidating, has now been reduced and simplified to 1 over 2. All you need to do is just to follow the rules. And once you follow the rules, you get solutions to your questions very easy. Now, to further explain to you further, I will take the last question, sample question for today. I enjoy solving mathematics, I told you earlier on, and I can't just stop solving it. Now, I wanted to stop from the third sample, but let's look ahead to solving the fourth and final sample for today. We're going to look at sample 4 finally. Alright, now let's look at the last sample question for today's video. And the question says solve 5 raised to the power 2 raised to the power x minus 1 times 5 raised to the power x minus 1 equal to 0.04. Now, do you notice that you are giving values with a decimal number? It's tricky, you know, but then we can solve it. So the first thing you need to do is to convert your decimal number to fraction. Now, let's look at that. You have 0.04. This is a 2 decimal place, so that will give you 4 over what? 100. This will give you 2 here will give you 2, and 2 here will give you 50. So that will give you 2 over 50. 1 here, 1, 2 here, 1, 2 here will give you 25. So that will give you 1 over 25. So you see, we've converted a 0.04 to a fraction, which is 1 over 25. Now we'll slot in that fraction there. And that will give us 5 raised to the power 2 into bracket x minus 1 multiplied by 5 raised to the power x minus 1 equal to 1 over 25. Now recall keynote 5. You have 1 over 25 will be equal to 25 raised to the power minus 1. So slotting that in, we'll have our 5 raised to the power 2x minus 2 multiplied by 5 raised to the power x minus 1 equal to 25 raised to the power minus 1. Now remember, 25 raised to the power minus 1, we'll have to make sure that these values goes to a common base. Recall what we did in our previous sample. Now 5 raised to the power 2 is going to give us 25. So this will now be equal to 5 raised to the power 2x minus 2 times 5 raised to the power x minus 1 equal to 5 raised to the power 2, all in bracket, minus 1. So what do we have here? We'll have this to be equal to, looking at the first law of indices, multiplication gives addition to same base. That will give you 5 raised to the power 2x minus 2 plus x minus 1. That will be equal to 5 raised to the power what? Minus 2, because 2 times minus 1 is minus 2. Now you look at the two bases are the same. They can cut each other. So what we'll have remaining here is what? We have 2x, the powers, minus 2 plus x minus 1 equal to minus what? 2. So you see, gradually we are coming to a conclusion. But all we need to do now is to collect like terms. Those terms without x will go to the right hand side, while those ones with x will remain on the left hand side of the equation. So we have 2x plus 3 equal to minus 2 plus 2 plus 1, right? So this will give us what? This should be x. So this will give us 3 what? That will give us 3x. I'm a bit faster there. This will give us 3x equal to minus 2 plus minus 1. That will give you automatically 0. So our final value there will be 1. So if we bring this up here so that you can see it properly, we'll have our 3x to be equal to 1. So our x here will be equal to 1 over what? Over 3. So the value of x, if we solve this appropriately, will give us 1 over what? 3. It's so delight getting the final result to this question. It's a great delight, really. And you can see now that, complex as it may seem, the solution is just straightforward. I guess you enjoyed these sample questions, and I want you to take your time. Look at those quizzes that will be given to you now. They are all on indices, and they are all past mathematics questions on WAEC. Now, I want you to take your time, go through them. If you have any difficulty solving them, let us know. I'll see you in the next video.